Yep. All right. So hopefully, I should have these corrections done. I'm hoping before Friday's class. May not happen, but I will do my best. Hopefully, then you will see as I work through these, I'll get those scores updated on Canvas, kind of your numbers correct, and then your corresponding grade or corresponding exam grade, and then I'll kind of have that weighted according to the syllabus as well as the current homeworks and kind of iClicker online quiz points to kind of give you also a reflection of where your grade is at after the corrections as well. Okay. I think I mentioned last week I might over fall break put up the next homework assignment. I kind of already had it created. I was just maybe going back through it and realized we haven't really covered that much, so I was going to hold off until we get to today's class. After today's class, you will see that pop up there, and now after today's class, you probably will start to get to make a little bit of headway into those first few, try 4 or 5 problems. Okay. All right. Oh. So, I think that's really you left off thinking about kind of costs and the firm's production decisions in order to maximize profit. You can turn it at the end of class if you didn't already turn in your corrections. I can kind of take those at the end. And also, I know I'm going to want to use this, and I forgot to just hit start. Okay. So, kind of ended on this slide, and I kind of gave you this idea where we know that because of this diminishing returns to labor, when we think about measuring costs in terms of dollars, we said our marginal cost curve maybe initially kind of has this kind of gain from specialization where our costs are marginal costs are decreasing, but the vast majority of our marginal cost curve is going to be increasing, right? We're using kind of the less and less effective inputs or less and less effective workers or raw materials. And then kind of gave you this idea about, okay, which ones, how many units would I decide to produce? Well, our equilibrium price, right? We're just going to have to take the market price as given, right? We're one of 1,000 firms. And so for all these quantities, the marginal revenue or that equilibrium price was much, much greater than the marginal cost. So we would produce all of these up to the point where the equilibrium quantity for the firm is where kind of that marginal revenue, marginal cost would be the same, or that equilibrium price of the good is the same as their marginal cost. That's where we left off. So today we're going to talk about some of the additional costs that go on. So we're going to kind of get rid of this marginal revenue for a second, talk about some additional costs, and then kind of put it back in there to understand firms shut down decisions. Okay. So we've got these marginal costs. We also have a couple other things, right? We've got fixed costs, variable costs, and then total costs, which is just the sum of those two. So fixed costs, you want to think about it like we already talked about sunk costs, right? Now, my fixed costs have to be paid no matter if my fixed costs have to be paid no matter if I produce 0 units or 100 million units, right? They are what they are. This is like the cost of the building, right? Whether or not I decide to produce this next month, I still have to pay that lease on that building. Right? So variable costs are generally more what we think about as like employee wages, right? I can increase the number of workers, but as I increase the number of workers, I'm going to have to increase my costs, right? You know, one worker costs, I don't know, $40,000 to hire a second, and it's going to cost me $80,000, right? So I've got how much I want to produce. If I want to produce more, I've got to hire more workers. My variable costs will increase. Okay? And the total costs are just the sum of those two things. So we're just kind of breaking down total cost into 2 different components. So if you'll remember, we had this increase in marginal cost curve. So let's think about these different quantities. My fixed cost is always going to be the same, It doesn't matter if I produce 0 or 7 units here, I always have this fixed cost of $100. This is like the rent in the building. My variable cost, as I increase my quantity, should be increasing. So notice my variable cost went from 0 to 1 unit to 70, going from 1 to 2 units, now I'm at 120, right? And my total cost would just be adding those two up. So quantity of 0, my total cost is 0, but that 0 variable cost, so that's just 100 is my fixed cost. And then at a quantity of 1, I take my fixed cost of 100, variable cost of 70, so my total cost of 170. And then do this for every single quantity, I can kind of graph these out. So the visual here is kind of nice because it shows that my fixed costs are always the same. It's just this horizontal line. Doesn't matter how much I produce, I have to pay these fixed costs. Now my variable costs are increasing as I'm increasing the number of units that I want to produce. And then that green line is just my total cost. What should the difference between my total and variable costs always be in this example? So if my total costs are just equal to my variable cost plus my fixed costs, the difference between my total costs and my variable costs should always just be whatever my fixed costs are. In this example, my fixed costs here were 100. So kind of the gap in between that green and orange line should always be 100 there. Okay. Any questions in that? So how do we calculate maybe these variable costs? A lot of the times in the examples I'm going to give you, you're going to be told what those variable costs are, right? So you'll be given some type of a table like this, where you have the different production possibilities, quantities, and then you have the corresponding variable, fixed, and total costs. Okay? Now, marginal costs, right? It's a little tricky here. So I have these values up here today. I want to make this point. So do I add on this statement? No. I'll do it up here on the board. Let's think about we'll go back here and I'll fill this out so we can kind of make this comparison. So I have 100, 0, 170, 70, 220, 120, 260, 160, 310, 210, 280, 280. So when I'm thinking about calculating my marginal costs, from last class we said it was going to be the change in total costs divided by the change in quantity. Okay. Now here, my change in quantity are easy. I'm just going up by 1 unit. So I'm really just looking at, well, what's the change in my total cost? So that's how I'm coming up with those values, right? What was the change in my total cost? Well, from 0 to 1 units, my total cost went up by 70. So the change in total costs for every unit I was producing, 70 to 1 or 7. You go from 1 to 2 units, so going from 170 to 220, difference there is 50. Divided by how many units they increase, so I just increased by 1, so 50 over 1, or 50. I think I did the same thing all the way down and come up with my marginal cost for moving up to higher and higher quantities. One thing I wanted to point out is kind of interesting is, if I didn't have these total costs, right? So let's say you just couldn't see these values, and all I gave you were variable costs. If I think about it, the change in my total costs, if my total costs are just composed of variable and fixed, one of these never changes. Fixed costs never change. So all of my changes in total costs are solely coming from my variable cost. So notice if I look at my variable cost column, I can actually compute marginal cost here as well. Going from 0 to 1 units, I went up by 70. Change in quantity was 1, so I got 70. If I've got going from 1 to 2 units, my variable cost went up by 50. I'm only going up by 1 unit. I get a marginal cost of 50. 120 to 40, 40, sorry, 120 to 160, 40 over 140. Notice I'm getting the exact same values as when I compute marginal cost from the total cost. So the change in the total cost is really just coming from a change in variable cost. Another way I could think about this is change in total cost would just be the change in variable cost plus the change in fixed cost. But my fixed costs, I said, are always the same no matter what quantity I produce. So when I'm looking at different quantities, the difference in my fixed costs will always be, well, it's never changing. So this is always 0. So the change in my total costs or the change in my variable costs, I could use cost. From that, moving. So just to kind of give you a little bit of insight, if instead, just because I kept this example kind of easy, let's say instead I have these jumps in quantity of 10 units, like I don't know, for whatever reason, my production process, I can only increase the number of units by 10. The only thing that changes here is I'm still looking at the change in variable cost. It's just now instead of dividing by 1 every time, what's my change in quantity? I'm going up by 10 units every single time. Right? So you won't always see 1 there. A lot of times you will, but I want to just kind of make the point that you could see different changes in quantity other than 1. I'm just kind of keeping it simplistic here for right now. And I already mentioned this at the beginning of class, right? We've got increasing marginal cost. Maybe potentially there's a little dip initially because of gains from specialization, but once we kind of work through some material, we'll kind of see we don't ever really have to worry about that portion because we're always going to be out somewhere on the portion where marginal costs are increasing when it comes to, well, what quantity maximizes profits. So when I say marginal cost might be constant, this is way down the road. It's some natural monopoly stuff. I might be some kind of goofy example. I shouldn't say goofy, just some unique examples that we might see pop up as a real world. Okay. So if I'm putting everything, sorry, not everything in. Still need to tell you about average. So here we're just thinking about total cost, variable cost, fixed cost. Right? We can turn all of these into averages pretty easily. Right? So if I ever want to find an average, all I'm doing is taking whatever I'm interested in, right? So if I'm interested in total costs, how do I find average total cost? Well, average total costs are just my total cost divided by quantity. What if I want my average fixed cost? Well, those will just be my fixed cost divided by quantity. Right? What if I want to find my average variable cost? Well, that'll just be my variable costs divided by quantity. Right? So to turn things into averages, right? I'll just look at whatever I'm interested in and divide it by the total quantity I'm currently producing. Okay? It kind of makes sense. Like if it costs, currently I'm producing 100 units and I'm spending, my total costs are $1,000 on average for each unit. I'm spending 1,000 over 100 or $100 or sorry, $10 in each unit. Okay? So that's all we're doing here is kind of converting these into averages by dividing by the total quantity. So what should happen with average fixed cost? So fixed costs are never changing. So the average, when I'm dividing by the quantity, as the quantity goes up, this number in the numerator never changes. So what's going to be happening to my average fixed costs? So the fixed cost never changes. But if I go from 1 unit to 2 units, I'm dividing by larger and larger numbers. My average fixed cost will actually always be declining. Because the number in that numerator, my total fixed costs are never changing. So if I then just produce more and more, you can kind of think about it as, well, I'm taking whatever like the lease of the building is, and I'm spreading it across more units. If I'm only producing 1 unit, then my average fixed costs are, well, all my fixed costs are going to that 1 unit. But if I'm producing 100 units, well, I've now taken that same lump sum amount, that same fixed cost, and I've spread it over 100 units. So by producing more, we can decrease our average fixed costs. Okay. And like I said, kind of like it's being spread out across more units. but it's still the same amount, right? Same total cost, so same total fixed cost, just spread out over more units. So as we increase quantity, we always see that we have this average fixed cost that's declining. So if I'm thinking about graphically what that looks like, and here, I'm always using just the dollar amount, like whatever the cost amount is my y-axis. Basically, gonna look something like this, right? That as I produce more and more units, I'm just decreasing that average cost, getting it closer and closer to zero. So, looks something like that. Right? And that's just the actual points in this table plotted out, but it's always going to have this downward slope. Okay? What about average variable costs? Well, these are a little tricky. So we want to compute our average variable cost. I'm going to go through, just take my variable costs and divide them by the current quantity I'm producing. So here, it's just a matter of taking every variable cost and dividing it by the quantity right next to it. So 70 over 1 would be 70, 120 over 2, 60, so on and so forth, right? And I kind of gave that equation, but here's our average variable cost. So kind of an interesting thing is going on with our average variable cost. You'll notice that at first, as we're increasing our quantity, what's happening to average variable cost initially? They're actually declining, right? If I go from 0 to 1 unit, well, I guess 0 is not it. So from 1 to 2 units, my average variable costs are down. Then when I go to 2 to 3, they're falling a little bit more. But eventually I get to this point where I'm having to hire more workers who are even more inefficient, but I'm paying the same hourly wage until eventually I end up with these average variable costs start to increase. So initially, right, I'm hiring more workers, I'm spending more money, but I'm spreading it out over more units. And each worker I'm hiring might be producing an additional, I don't know, couple hundred units, right? By the time I get to my 7th or 8th worker, maybe they're only adding 10 or 20 units, but their salary or their cost is exactly the same, or whatever that hourly wage rate is, if it's easier to think about it that way. So for our variable costs, we kind of get this, well, I think I've got it on the slides here. We get this kind of like U-shaped curve, right? Yeah, so we get this nice kind of U-shaped curve here. So we've got average fixed costs are always declining. Average variable costs initially decline, but then as we produce more and more, eventually begin to increase over time. So this is due to the fact, once again, that we have these increasing marginal costs that our workers are becoming more and more inefficient. Now, average total cost, I can find one of two ways. Right? I could just take the total costs and divide them by my quantity. Right? So I could 310 divided by 4 would be the average total cost when I'm producing 4 units. 620 divided by 7, the average total cost when I'm producing 7 units. But another way I could find them is kind of similar when I'm thinking about these changes. I can break this down, and this might be more helpful for some of you who I guess are a little bit more mathematically inclined, but I'll kind of explain it afterwards when we get on that. So I think I already told you this. I think this is a pretty easy concept to grasp, right? My total cost are just my variable cost plus my fixed cost. Well, if I divide both sides of this equation by the exact same thing, it doesn't change that equality sign. If I divide both sides into 2 numbers, it still doesn't change anything. So now this represents average total costs. Variable costs over quantity are my average variable costs. Fixed costs divided by the quantity are my average fixed. So just like total costs, I could just add up my variable and my fixed costs to find my average total cost. If I, instead of only giving you like this column and this column, well, I could have just added up my average fixed costs and my average variable costs to reproduce the average total cost as well. Okay? So kind of, there we go. Multiple ways of doing this, right? I could take 380 total cost divided by quantity of 5. I get the average total cost of 76. Or if I had already done the work to find my average fixed and average variable costs, well, notice I take my average variable costs plus my average fixed costs here, that also gave me my average total. Kind of two ways you can calculate that kind of depending on what you get. Any questions? Before we keep going. Another way to think about this is, so I've got these total costs, right? When I'm dividing them by the quantity, it's like, okay, I'm spreading them across this many units. So on average, how much would my per unit cost? Average total costs are probably what, like, you usually hear a lot of, I guess, things you've heard maybe in the media, or you'll hear people talking about businesses, what they care about, right? It's kind of like their per unit cost. But they can break that down into two components. One of them is, well, how much of my total costs are just coming from these things I can't change, or these fixed costs, right? And part of my average total is just, well, part of these costs are fixed costs, and they're being spread over however many units I'm producing. The other part of my average total costs are, well, what are my variable costs, and how are those spread out over the number of units that I'm producing? And then adding those two up will give me kind of my total, like, per unit on average cost. So, won't probably dive too much into the reason why, but if we think about, well, I can try to rebuild. I'll try to do this one. I think this might help with that. Here's my average fixed cost, right? We said they're always declining. And then here's my average variable cost. What is the difference between my average total and my average variable costs here? What's the difference between my average total and my average variable costs?
Well, didn't the average total also have to fix?
Yeah, right. So if I'm thinking about rewriting this to be the difference between my average total and my average, like the difference between those two lines, well, that's just going to be whatever my average fixed costs are. So notice, initially, if I'm thinking about adding these up, my average, I'm drawing this probably a little bit too dramatic, but right, if I add these two up, I'm getting something up here. But notice my average fixed is declining. So when I'm looking at my average total cost curve, it'll always be a little bit higher than my average variable cost, right? Because I'm adding in the fixed cost as well. But initially that gap is going to be much wider, right? You can kind of see why. Well, because as I produce more and more, my average fixed cost is getting closer and closer to zero. So the gap in between average total and average variable is getting closer and closer to zero. So my average total cost will also have this kind of U shape. But the only added thing we can also throw in there that we know is that as we produce more and more units, that U shape average total cost curve starts to get closer and closer to that U shape average variable cost curve. And the reason why is because the difference between them, or my average fixed cost, is always getting closer and closer to zero. So if I throw this here, I'm going to skip ahead. There we go, a little bit, right? The marginal cost payment being the Nike sign, right? But we've got kind of all of them laid on top of each other. My average fixed costs are declining. I've got my Nike shape with this kind of check mark looking marginal cost curve where it maybe initially decreases, but then it really spikes up. And then I've got kind of these U-shaped average total and average variable cost curves, and they're just getting closer and closer. Okay? So we kind of have the legend here, so having them labeled kind of like I did up here on the board. But this is kind of building everything all together onto one graph. Now, after today, we're going to be concerned with average fixed cost, but usually when I'll draw this out, we will only be kind of looking at my marginal cost curves, average total costs, and then average variable costs. Usually I'll leave fixed costs out of it. We want to get the shutdown decisions. These are the only curves that we're really focused on. So we've got all these equations, right? And it might look like a lot, but remembering really, I mean, all these averages, essentially the same idea. If you want the average total cost, average fixed cost, average variable cost, you just take that cost we're interested in and divide it by the total quantity that we produce. And then marginal cost is the one that's a little bit different, which is where we were calculating the change in our total cost and dividing that from the change in whatever our output or our quantity is. So, skip ahead here. I don't know why I had all this kind of sectioned off into different colors. I guess maybe think about these are slightly different. These we would kind of group together because they're all averages. We've talked about all of these now. Let's try to walk through this one together. So think about the best way to do this. I could do this on the board. So let's think about if I had something like this. I barely gave you any information. When I gave you enough information, it actually fill out this entire table. And it really relies on all the principles that we've talked about to this point. So one thing that, if you're given an example like this, if you're trying to calculate your cost of the quantity, it's pretty easy to do with fixed costs, only because we know they're never changing. So if I'm looking here, and I said, okay, where's my fixed cost or my total fixed cost column? I don't have any information. Okay, but at a quantity of 0, what should my total variable cost be? 0. So at this quantity of 0, what would my total fixed cost be? Yeah, if I know that my total cost is 720 at the quantity of 0, my total costs are just my total variable plus my total fixed cost. Well, I just said these are 0, so it's just going to be my total cost or whatever my total fixed costs are. So now what could I do? At every single quantity, total fixed cost is 720. I now have an entire column, right? I can plug in 720 all the way down. I think that's hopefully the steps in which are the order in which I did. Okay, I put all of it up here at once. So we'll try to fill this out as we go. So I've got 720 all the way down here. So if I then want to find my average fixed costs, what's the process for which I'm going to do? I want to fill out this column that's completely. Well, if I now know that my fixed costs are always 720, how can I find my average fixed costs?
You divided by the quantity for each one.
Yep. So this first one, kind of weird. Anything divided by 0, we can't actually come up with a value there. So our 0 row is always going to be a little weird. That's why they have those dashes. First one, 720 over 1 is 720. And we would do 720 over 2. So what? 360.
Yeah.
And then we would just kind of continue to fill that entire column out using that process. So we would then have kind of our total variable. We would have our total fixed and our average fixed cost. This is where it then gets a little bit more tricky. So I'm going to write this whole table out and we'll try to kind of start taking pieces of it away. But I want to do the fixed cost first because those are generally the easiest ones to kind of work through. So we'll go 0, 1, 2, 3, where I got before. Then have total variable, total fixed costs, which we just said were 720 all the way down. Got total costs, average variable, average fixed, and then cost, and then we'll do marginal cost at the very end. So I'm running out of room here. Okay. So we're then going to go where we have some other information and see, can I fill anything else out in that row? So if I know my total variable costs are 7, what else could I figure out pretty quickly here?
Total cost.
Total cost? Yeah. So why could I find total costs?
It's just the total variable cost and fixed cost.
Remember, that was just my total fixed cost plus my total variable cost. Well, for the first quantity of 0, my variable cost is 0. Well, now they're a little bit higher. So now my total costs are 727. We had our average fixed costs here were 720 and 360 initially. I have to try to do some of the math in my head. So, or actually, sorry, my bad. I need to do this here. 720, 360, 720 divided by 3 is going to be 40, no, 240. And then the fourth one, I've got. That'll help. 720 divided by 4. 180. So from here, what else can I fill out in this row? This one right here for a quantity of 1. So the only other things I need to find right now are average variable and average total cost.
So average variable is
Okay, my average, I just take whatever I'm interested in. Here are the variable costs. 7 divided by my quantity of 1, which is 7. What would my average total cost be? Just take my total cost divided by quantity of 1, right? So when I have a quantity of 1, I said 720, I think I'm at 727 divided by 1. So all I'm doing there is taking that total cost, dividing it by the quantity. So it's easy for that row where I've got quantity of 1, because dividing by 1 is easy. So then we'll go to the next thing that we know. So we'll go down here, okay, at 2, we were also told that total costs were 740. So if I know my total costs are 740 here, well, right away, if I've got all my quantities, as soon as I know my total cost, what can I instantly calculate? If I take my total costs,
variable cost. Average.
yeah, right? So no matter what other information I have, if I know my total costs and my quantity, I can always find my average total. So here, what would I do? I would take my total cost of 740, divided by my quantity of 2. So 740 over 2, what, 370? I'm doing math in my head correctly. Yeah. Okay. Someone also mentioned it, that from what I do have, I can also find something else pretty quickly. Now, if I know my total costs, and here I'll write these out so you can see them, and I know my fixed costs, what else could I find pretty quickly? My total variable cost. Why? I think the difference between these two will just be whatever my variable costs are. The difference between those two is 20. I know that my variable and my fixed costs always have to add up to that total. And then from there, once I know my total variable costs, I can find my average. So 20 over 2 or 10. I go down to the next row. So I've got my average.
Variable cost.
So 3, yeah, so right. So if I've got my average variable cost is 15 here. This one gets a little tricky. Yeah, so think about here. I've only know 2 pieces now. I know that this is 15. I'm trying to find my total variable cost, and I'm at a quantity of 3. So it's just a little bit of algebra, right? Multiply each side by 3, and I get my total variable cost there. Once I know my total variable, and I know my total fixed costs, I can find what?
And
Total costs, which would just be
some
the sum of these two. So 765, adding the two. Total cost is just the sum of my variable and my fixed cost. And then from there, what's my average total costs? Well, my total costs are 765. This one I won't be able to do in my head as easily. All right, 765 divided by 3, 250 something, right? 255.
Yeah, things have added to.
Yeah, there's another way I could do it too. You're right, right? So that way, because I think it's the easiest, right? If I know the total cost and I know the quantity, I'll just divide my total cost by the quantity to produce the average. But I also know that my average total costs are the sum of my average variable and my average fixed. Well, I already had my average variable cost of 15. My average fixed cost of 240. Notice if I add up those two averages, I would also get 255. So kind of two ways of doing it there. So I had enough information. And in the very last row, I've got what total costs are. No, average total costs are 202. Right? So from here, once again, it's going to be a similar strategy. I know the average total cost. Well, I know that's just going to be my total cost divided by quantity. So if this is 202 at a quantity of 4, it's going to be a little bit of algebra to get that my total cost would be 4 times 200. So sometimes, we can plug things into our average equations, and we're going to have to do a little bit of algebra there to solve for the one thing that we don't know. Here, the one thing we didn't know was what were total costs. So we now know that those are 108, right? Or 4 times 200. From there, how can I find total variable costs?
That from 720.
I know my total costs are 808. My fixed costs are 720. The difference between those two will just be, well, what are my variable costs? So the difference between 808 and 720, 88. And then I have one thing I didn't do. Average variable. So there we go. So there I'll just take what? 88 divided by 4 or 22. So I know it's a lot. We're just kind of showing you a lot of it's going to be getting used to using these formulas and kind of, it's not like every time you have to fill out an entire table like this, but those relationships between how do you calculate the average? Okay, write that out. What do I know? What am I looking for? I might have to do a little bit of algebra. Knowing that total cost, fixed plus variable cost, average total cost, average fixed plus average variable, will kind of allow us to, with very limited information, know a lot of other things. Now, I left off the marginal costs column here because we did a lot with that last week, and it's not on front end. It's if I'm just looking at what's my marginal cost, it's just the change in my total cost divided by a change in quantity. Well, here our change in quantity were always 1, so it was really just always kind of the difference between my total cost, right? So for this very first one, we had to think about, I really should be using 0 here. Sorry, I've got 720, so 720, 727. The change in total cost was 7 divided by my change in quantity of 1 plus. And then the next one, 727 to 740. Well, that change in total cost from that second unit was 13 divided by the change in quantity of 1, 30, right? And so on and so
So let's say, would it be pretty different if it was going up by a quantity of 2? So it'd be like divided by 2.
Yeah, it was actually going up by 2. What would be true? Let's say all these values were the same that I started out with, but the jumps in quantity were 2. Everything would basically, well, everything would be double, right? Because instead of dividing by 1, or sorry, changing 1, I'd be dividing by 0. Didn't say it's double, somebody hacked my bad.
Yeah.
Right, so we're dividing by the values double. When we divide by that value, it's going to cut everything in half. So, yeah, but the only thing we change would just be dividing by 2 instead of dividing by 1 here, calculating marginal cost. Okay. All right, come back to this other thing. So I think I want to point out a couple other things here. I said initially we might have these like in these simplistic examples. Initially, we might not see as much of that U-shaped curve because it's not as kind of a continuous. I'm not looking at really anything that has some changes. So in an example like this, you'll kind of notice like my total variable cost and my total cost don't really have this U shape. They're kind of starting out. So instead of being able to kind of see that initial portion where maybe average total costs look like this, we might kind of start out at that bottom point where we then always see kind of average total costs increasing. In a lot of the examples that won't be the case, but in a simplistic example like this, that might be the way the numbers kind of play out. So don't let that confuse you. More often than not, in real world applications, we do kind of have this initial portion of that average total cost and average variable cost curve that are decreasing. So we have these kind of nice U shapes. I just wanted to mention that based off of these numbers. Okay. Anything else I wanted to mention here? I think we're good. Okay, so got kind of a conceptual question to get an idea of kind of how we're following the discussion of everything in that table. So suppose that we see the wage rate that the company is paying employees. In terms of our cost equation, which of the following is going to be true? So you've got these different combinations of total costs, average cost changing, or anything. So what we're thinking about here is our wage rate, right? That's one of the things we said that is variable, is the number of workers we hire. So that wage rate should be a variable cost. So if that wage rate increases, excuse me, which of the following would be true, right? So that's going to impact some costs and not impact others, okay? So if I see that my workers are paying a higher wage rate, so changing my variable costs, which of the following would be true? And kind of talk to people around you, think about the equations maybe that you would calculate the averages, think about how we find these different costs, and then we'll talk about it here in a minute or two. And think through every single answer, and it should be pretty obvious which one is right.
Should only be like
All right. If you haven't gotten an answer in, take your best guess here. You've got 35 people here today, 37. Should have 40 people here today. All right. So let's think of so which of these is the right answer? D. Why is D the right answer?
Because a fixed cost does not have it.
Right? If our fixed costs are completely unaffected by our variable costs, right? So nothing with our fixed costs is going to change. Well, if our average fixed cost is just our fixed costs over quantity, if fixed costs don't change, our average won't change either. Our average fixed cost. But I want to think about some of the other answers, why like you could really rule them out pretty easily, right? So think about A. Will total costs increase? Well, total costs are my fixed cost plus my variable costs. So if my variable costs go up, what happens to my total costs? Yeah, they have to go up as well. But what about my average total? Well, if my average total is just the total cost over quantity, if total costs are increasing, then my average total costs have to be increasing as well. So that can't make it, that doesn't make any sense. Total variable cost will increase. Well, that makes sense, right? Because my variable cost, I already mentioned that, and setting up the problem, right? Labor is a variable cost, so those should increase. But once again, if I'm thinking about my average variable cost, that's just my total variable cost over quantity. So if my total variable costs are going up, the average would have to be going up as well. This says the average is increasing. And then C, the marginal cost curve will become hill-shaped, looking like this. We know that can't be the case. We know that as we produce more and more, we're actually going to have that we're going to see increasing marginal costs, not decreasing marginal costs. So that one doesn't make any sense. The answer there should be D. Hopefully, we're kind of following along pretty well. Let me think if there's anything else I want to say. So we got like a couple minutes left to kind of set us up for next class. So we've got all this. We'll talk about this relationship next week. So what I want to start thinking about for next class is we've now got this entire cost structure finally set up. And we're going to think about how do firms become profitable. Okay? So we're thinking about profit. We can think about this as total revenue minus my total costs. Okay. So another way of writing this would be, well, total revenue is just, I have to take the equilibrium price for this good is what it is, right? I'm one of 1,000 companies. We can only get charged this price for gasoline. Multiply that by the quantity I'm selling. And then we can also think about that I could rewrite my total cost, which is going to seem kind of weird, but I could rewrite total costs as this, because Q over Q is 1, so multiplying by 1 doesn't change anything. But notice, what does this represent? Average total cost, right? So I actually can rewrite my equation like this. If I then rearrange things a little bit, what I can find out here is that when our profit's positive in this equation, anytime the equilibrium price is above my unit cost or above my average total cost, right? And then when are my profits negative? Whenever the equilibrium price of the good I'm selling is below my average total cost, right? My per unit cost. Because this is like my per unit revenue, this is my per unit cost. And the point where profits will be 0 is when these two are exactly the same. So we'll start to talk about the relationship between the equilibrium price of the good and our average total cost as well as our average variable costs. Like I said, you can probably get a good chunk started on that homework once you see that pop up here this afternoon. Other than that, didn't bring your corrections and make sure you do so on the way out. And I will see you guys on Friday.